Hey there, dear friends. I hope you all are doing well. Let's start our new session, which is session 15. So we have completed this part so far, as you can see. Then in the continuation, as you can see, I have added these lines. Afterwards, I want to separate them all. And let me unlock these. Let me separate these as well. Great, I open the locks. Afterwards, for the length, which is the total length of the beam, I specify 300s, and then I click on OK. So we should not have any line on them. Here there are two reference planes, member right and symbol. I remove them. After that, I want to lock the reference plane to the member right. We use this to control the extension of the extrusion. But these must be the same to each other, so put this into consideration. And let me reduce the length of the reference plane, and then I move it. Here I just placed it there since I want to select the left reference plane, not member left. Of course, I want to reduce the length of member right reference plane as well, and then I place it there by this way. And then here, as you can see, we got two lines. Two of them are the offsets. Here, as you can see, there is an offset between the last rebars that are placed on the beam, while we can see the bar ends that are reinforcing beam because of a negative value in extension. So we get back to Revit, and then I add two reference planes by this way. Let me add a line dimensions from the main line like this way. I select them both and associate them to offset parameter instance and OK. In fact, by defining offset, we are specifying the start point of the bars. However, we can specify a fixed value for it like 20. Check this out. And then when I increase the value like 400, as you can see, the offset is fixed. Right now, I just wanted to test the parameters and check if it works out correctly. And following that, we're gonna have too many parameters that they must work together properly. Anyway, after that, I want to add these bars. But before propagating it on the beam, I want to change the parameters. Firstly, we got the bottom wide. I want to move the bars toward the concrete beam, so let me associate it to a new parameter. I name the parameter bottom opening instance and OK. Well done. Then to specify the value, I want to define a formula. Firstly, I want to copy the width of the concrete beam. I paste the width of the concrete beam there, and then I want to subtract 6 from the width. So right now, as you can see, the opening width of the bars are reduced. And for controlling its length, I name it bar length and OK. Bar length and OK. Then for specifying the value of bar length, before that let me associate another parameter for controlling its height. Bar height. I want to control the top longitudinal bar height. I click on OK. Let's see what is left. Right now I need to associate the parameter of top width. That, as remember before, the top width was equal to bar diameter, longitudinal bar diameter actually. And then the next one, which is the inclined armature diameter. I click on instance and OK. Very well. Afterwards, we got these two offsets, and then I draw these two reference planes as well. These are very important. Then I add the align dimension between the offset and the two new added reference planes, assigning them, connecting them to a parameter, naming them a space. Space is a variable that places these two beside each other. Let us align the inclined bars at the center. Don't forget to lock it. And then I constrain or align the endpoints. Here in family parameters, I want to control the inclined bar length, 45 for instance, based on the bar type that you are using, or even for D. Then I select it, I want to array it, move to last, then I place the last item. Afterwards, I align it with a space reference plane, and also I align and lock the central line. Then let me associate the number of the inclined bars to a parameter n. Following that, I want to define a formula to divide the inclined bars on the beam. I mean, we are going to add the two offsets, afterwards subtracting space, then we want to subtract the result from length to total length, afterwards dividing the result into opening length and calculating the number. Let me open the notepad since I want to define the formula correctly. So firstly, I copy length and then I paste it here. I subtract length from, then inside parentheses, offset multiplied in 2 and closing parentheses. Let me add parentheses by this way. After that, divide it into inclined bar length. After that, I paste the formula for number. As you can see, the given value is 7. Watch this. However, the number is more than enough and I can consider a variable to reduce the number. For instance, let me create another parameter and then I name it end, since I want to remove one inclined bar from the end. Let me create this parameter again since I forgot to adjust the variable. Then I set the parameter type integer number and OK. Afterwards, we get back to Notepad and then I place the entire formula inside parentheses. Then I add minus end. Let me paste the formula for number by this way. Then if I set 1 for end, then it removes one of the inclined bars. Right now everything is okay. Watch this. And as mentioned before, I have placed the inclined bar ends inside the beam, and also we have considered the offset between the beam end and bar ends. In the continuation, I want to define a formula to adjust the spacing of the inclined bars based on the remaining value in space. Anyway, let me create a new parameter. I name it as in other group. Afterwards, let me copy this and then I paste the formula here. I add minus. Let me copy the inclined bar length. Then I want to multiply it into n. So just wait for a second. I wanna add n parameter and then I want to multiply it into the inclined bar length. We can close the parentheses, and then we paste the formula. Then let's see what happens. Offset. Well done. Afterwards, let me fix this, and then I paste it for S. Here, as you can see, the value is 20. Let us have a review. Firstly, we subtracted 2, multiplied into offset from length. Afterwards, we calculated the entire length of the inclined bars. As you can see, we got 6 inclined bars. Following that, I must divide 20 into 2. Let me set the group parameter to other. Let me divide S into 2 to consider the value for space. Then if I click on OK, watch this. The space is 10 and they are arrayed. So if we increase or reduce the value of length, the inclined bars will be arrayed and the spaces will be adjusted automatically. And they are not overlapping, guys, they are just placed inside the concrete beam. Let us test it again. Watch this. We can add them by placing 2 points. Even we can modify the offset. Watch this. The offset is 50. I can't decrease it like 15. Look at this. Also, we can keep the extensions by using the shape handles to modify them. If I set 0 for n, they will be mixed up. So here is the result. After that, if I get back to the reference level view, let me check the value of offset 20. We can round the values and then load them into the project. Then it's time to draw the longitudinal bars at top and bottom. We open the left view and then I draw a reference plane here and I added a aligned measurement. Let me associate it to top armature height like this way. So it enables us to control the top armatures or rebar height. I'm talking about the longitudinal rebar height. Then in family types, let me test the parameters. 30 for the top longitudinal bar height. Watch this. Then let me set the work plane. Reference plane in view left or left view and OK. Then here, as you can see, for the height of the longitudinal bar, I could have specified the bar end of the inclined bar actually. Let me remove it since I want to choose the inclined bar end. Let me try again. It didn't work out. Forget about it. I want to add the extrusion. Let me set the work plane in left view reference plane. We'd better to draw it right here, the extrusion. Look at this. I draw a circle and then I select it. I want to add the aligned diameter by this way. And then I want to associate it to a parameter, longitudinal bar diameter. I think I have created a parameter for it before, so let me associate it to the previous one. Let me reduce the scale. I want to move it downward by drawing a reference plane. Let me see. I can draw the reference plane at the center of the circle. Afterwards, adding a dimension, align dimension. I select it and make the center visible. Then let me lock the center of the circle to the reference plane. Align and lock. Then if I change the longitudinal bar diameter 10, apply, 10, apply, or 1, okay. Then where should we place this? Afterwards, I want to align the end of the rebars with space reference line at the both sides, and then I lock them, both left and right. Let's check it out in the 3D view. However, we can adjust them more, but there is no need to be sensitive here for the spaces and distances, since they are going to be welded. I load it into the project for one more time, and then as you can see, we can control its length. Then let me change the bar diameter for the top one. I set 1 or 10 millimeters or 1.2. As you can see, we can control the bar diameters, the longitudinal bar diameters, and also the bar openings are changing as well. But if we adjust the position of the reference planes, we can add some intersections between these bars as well. Afterwards, I want to open the left view by this way. Let us add 3 tension bars at the bottom part. So here, then adding aligned measurement, pressing down tab, and then I equalize them from the reference planes. As you can see, the middle tension bar is greater than others, so it is stronger than others as well. Firstly, let me open the left view, and here there is a connection between these bar ends to the tension bars. Let us take a look at the image. Watch this. As you can see, there is connection between these bars. I mean, we should place the inclined bars in a way that to make the connection between the inclined bars and the tension bars. Here the length is 12.5. Let me measure it. Let me see where it goes if I extend it like this way. 12. As you can see, 2.27. We can position it at 1/3 of the beam. So create tab, adding 2 reference planes like this way. Watch this. And then I can lock it to these reference planes as well. Let me test it and check what happens. Look, it won't move if we associate it to that reference plane. I think it's better to define a formula for it. For instance, we can divide the beam into 6. Let me see, 3. And I want to associate this to a parameter. I name it left offset. And okay. Afterwards, let me see, how can we define the formula for it? For example, let me check the beam width, and I want to divide it into 3. Actually, as I mentioned, I wanted to divide it into 6. 3 parts at each side and 6 for the entire parts. Control X, and then I define it for left offset, and okay. I think there is a problem. Let me check this out. Control X. This, I should remove the lock, and then I associate the parameter and defining the formula. Left offset. There was a constraint there because of the lock that I had to remove it. And then for the other side, left offset. Well done. Then I want to test it. For instance, if I modify the beam width like 30, watch this, or if I said 20, good. So everything is okay. Then I want to add the tension bars in here in extrusion. Firstly, I add the circles, adding bar diameter like this way, and associating them to a parameter. I name it tension bar diameters for both sides instance, and I want to consider 10 millimeters bar. I specify 1 centimeter. Then I want to add another bar, tension bar at the middle part, adding the diameter, adding a new parameter, central tension bar, central and lateral. So we added the value for diameter, and then let me select these three and hide them. After that, select them all and then make the centers visible. Then I want to align the centers to the reference plane, as you can see, to make them aligned, and like this way. Okay, finish the changes. Then, as you can see, I want to set all of these parameters that are controlling the bars under structure parameter group. And then the next one, like this way. The next, I choose structure or structural. We got 4 types of bars here in this project: the longitudinal, the inclined, the lateral tension bars, and the central tension bar. Okay, we are done. We have set the group parameters under structural. We save the project, getting back to reference. After that, I wanna pick the tension bar and then extend it. And don't forget to choose the main reference, which belongs to the length, total length. Right now we are done with this. Then it's time to associate materials. I add a new material. I name it armature materials. And then in asset browser, I want to consider a material for it, or an asset actually. Let me see, in metal, I scroll down, let me see, rusted iron, here it is. I choose this asset for it, and okay. Realistic visual style, look at this, and then let me choose the longitudinal bar and associate the rusted material, and also for the inclined bars as well. However, we can create a parameter for it, so then we can specify other types of assets. I want to add some fillets to the corner or edges of the bars to just beautify it. Choosing fillet, not 0.1 or not 0.5. Better, like this way. For the beam, like this way. Anyway, it is more complete now. Done, let me check it out. However, I can move the longitudinal bar a little bit downward as well, but it is not necessary, I think. It's okay. There's no need to change. Let me choose the beam and then choosing concrete material for it. Great, like this way. Well done, load it into the project. We're gonna test it here. and check if there is an error. Here in realistic visual style, here we can add some values for start and end extensions, which is -10 for both sides, start and end. As you can see, we can see the bar ends. Also, we can change the value of bar covers, and we can add offsets for the bars as well. Let me see, offset, I set it to 5 or 10. But here the offset didn't make any change because the spacing is being adjusted with a space parameter, which is right. We are drawing these two as well, and then test other parameters like width of concrete beam by this way, and if I change the beam height and top longitudinal height, and also we can control the left offset. Let's check it out by this way. That 3 is enough for it. So our concrete joist is completed so far, and right now I just want you to put time on modeling this from scratch with patience, to just model it parametrically, just like how I taught you in this and previous session. However, there is another point left that I should mention it here in this part. Let me see. Here we can align and lock the first and the end with this, member left or member right. So then when we modify the length of the beam, the inclined bar's opening will change too. We don't do this because the bar lengths will be mixed up, so we do not align them to the member right and left. And note that if you model this just only for one time, you can save the family and then use it for other projects as well. Let me find the main element or family I want to save it, and then use it in our projects as well. Don't hesitate to ask if you had any questions, and in the following sessions we're gonna learn how to combine this with the styrofoams. And as we are at the end of our session, let us test our beam. We get back to project, and then we want to add the concrete joist. We load it into the project, and then let me see, structure, beam system. Here we got the concrete joist. Let me adjust the fixed spacing like 60. Watch this, if I add them here by this way. Afterwards, we can control their height. Let me show them in realistic visual style, like this way. Then we can extend the longitudinal bar to put them inside the beams. Later, we're gonna adjust the bar lengths, the longitudinal bar lengths with the other beams. Let me set the end 0 here. Here, as you can see, when we set 0 for this, then they are connected to the roof, and they are being put inside the beam. So they are placed at the right position. So guys, please practice this part. It is very important. And then don't forget to test them. And in the next session, we're gonna add the styrofoams. I hope you enjoyed this session. See you next time.